Okay, so let's look at a short video about that site of Ain Ghazal, where you could see some of the human impacts on the ancient environment in the Neolithic time period.
In 1974, Jordanians digging a main road to Amman discovered the Stone Age ruins of Ain Ghazal. Here, Gary Rolifson was able to document on film the story of plaster.
What we're looking at is a Neolithic house with a beautiful plaster floor, with a central hearth for heating and for cooking and for light. The plaster is of excellent quality, very sophisticated.
Ain Ghazal was a large, impressive town with hundreds of houses. Plaster was part of its dazzle.
Every house had to have a lime plaster floor. That's expensive. It's expensive because lime does not exist as a natural resource. Lime has to be manufactured, and it's among the first artificial materials that were ever produced by humans. It comes from burning limestone. And in order to burn limestone, you have to reach high temperatures. The temperatures have to be sustained for long periods of time, and this requires a lot of fuel. Every time that you make a floor at these 50 square meter houses, we figure that you're using at least 6 trees.
Over 2,000 years, villagers had slowly changed the land.
Before villages got established, there was very little human impact on the environment at all. People were moving around. They didn't stay in one place for very long. They didn't have the opportunity to impact the environment. But now, as people are settled in one place, the impacts they do have can build on each other, and they can continue to affect the environment generation after generation after generation.
At Ain Ghazal, Rolifson found evidence of the crisis in the wooden posts that held up their roofs.
The posts that started out at up to 60 centimeters in diameter decrease gradually in size, and we think this reflects the absolute decrease in large trees that are in close proximity to Ain Ghazal itself.
Then the plaster began to suffer, even though they loved it.
It appears to be a mixture of mud and perhaps pounded chalk. I suspect that this represents, again, the lack of available fuel for the use of plaster manufacture. And in fact, in the hearths that the people are using for cooking their food, wood is no longer found. The remains of wood charcoal is no longer found. Instead, they were using animal dung as the fuel.
All the available wood grew on the nearby hills. Slowly, it became harder and harder to reach. Eventually, the supply could not keep up.
There is a deforestation that's radiating out away from the center of the settlement, and wood that should be renewable as a resource. But now we come into this problem with goats. One of the things that goats love are brush, and probably the sweetest brush there is a sapling or seedling. And so this is irreversible deforestation. As long as you keep goats around there, those trees are never going to grow back.
For the first time, human communities were destroyed by environmental collapse, which they themselves had caused.
Population at Ain Ghazal dropped, it plummeted from what may have been its height at 3,000, perhaps even more, down to several hundred people.
Towns like Ain Ghazal were finally abandoned. The archaeological record almost disappears.
Okay, by using oxygen isotopes as well as some of the other techniques that we talked about, we can look at why certain societies had a collapse, such as the Old Kingdom in Egypt. The Maya civilization had a collapse around 900 AD, And one hypothesis to explain why they collapse was deforestation. And what you can see is that around the time of the Maya collapse, you can see that there's a sharp drop in rainfall and what looks like an increase in temperature that may have been caused by too much land clearance for farming. In fact, in some of these Maya sites, you have evidence of soil erosion from the hills where the trees were cut down, leading to the rain washing away the topsoil, which probably ruined their agriculture. The same thing may have happened to the people of Rapa Nui, more well known as Easter Island. There are not many trees there today, but there used to be trees. Pollen analysis shows that there were trees on Easter Island. Birds used to live in those trees, and the birds and the eggs were an important food supply for the people of Easter Island. Some people believe that the people of Easter Island cut down the trees. Some people believe that rats destroyed the trees and ate the seeds of the trees. Either way, the end of the forest spelled a hard time for the people of Rapa Nui. Okay, how do you actually recover things like seeds and pollen from soil? Well, if you're digging in an archaeological site, and this is one of the things I did in Turkey, you would collect soil from primary context, because you know that would be good sealed context. Primary context is the best. You would collect that soil, and then what you would do is something called flotation. You would put it in a barrel of water, all of the soil, and the rocks, minerals, sand, things like that would sink to the bottom. Things like seeds, pollen, plant remains, other kinds of plant remains would float. You would basically sieve off the top floating fraction, and then a specialist in paleoethnobotany would look and sort through all of that material that floated and count the number of, let's say, seeds from this species versus that species. They would then do microscopic analysis to look at pollen, and so you'd be able to say, dating that level with, let's say, carbon-14 dating or pottery. You'd be able to say, okay, at this time period we found a high level of this kind of pollen blowing in from the surrounding area, and it's different than the time period before, showing that there was a change in the overall climate. Right? So again, this kind of work has been done throughout the world. Lake cores and lake levels and pollen. One good indication that you can get from seeds, right? So seeds found in the site are mainly going to be from what people eat. They'll be cooking the seeds, and some of the seeds will fall in the fire, and they'll be charred, and they'll preserve well. So the seeds will give you an idea of what people are growing. The pollen will give you an idea of what's growing around the site, and the pollen blowing around and then ending up in the site itself. Right? Well, there's a difference in barley and wheat, these two cereal grains that were so important in the Middle East. Wheat is less hardy and less resistant to drought and heat. Barley is a much more hardy crop. So if you see a switch or a transition in a site from people growing, let's say, a mixture of wheat and barley to then growing mainly barley, you can guess that or hypothesize that the climate was getting perhaps hotter, perhaps drier, or maybe both. Right? But also barley is more salt resistant, so it's resistant to salts in the soil. So you could, if they're growing mostly barley, where they used to grow wheat and barley, it means that the climate was probably getting slightly worse. Right? Okay, so you can do this for plants, but you could also do it for animals. This is something we'll talk more about when we look at zooarchaeology. For example, if, let's say, you find animal bones in an archaeological site from 12,000 years ago, and there's lots of caribou, 2,000 years later, there's much less caribou and more white-tailed deer, you would say again that there was a switch from colder environments to warmer environments. We find caribou in much colder environments up north, and white-tailed deer we find in temperate environments here in Michigan. Right? So certain species of animals are environmentally sensitive. They live in certain habitats. By looking for the bones of these animals in archaeological sites, we can help reconstruct the environment. Okay, and so this is yet again another piece that we can add to the puzzle. Okay, so climate is a big part of the way we understand the changes that have gone on through human history. It provides a background. We have to have an idea of what the climate was like, because it obviously had an influence on people. It might have produced strain. It might have provided opportunities. But like we said before, it would not determine the way people would behave. This is related to what we see today with climate change, right? And all of the data is clear. NASA, the National Oceanographic and Atmospheric Association, or NOAA, right? The U.S. Navy has data on climate change, as well as universities around the United States and around the world. It's clear that there is a sharp increase in temperature, in overall temperature, and this is having a very negative impact on our habitat, on the climate in general, on what we see in different areas of the globe. Right? For example, we see the melting of the Greenland ice sheet, and once the ice sheet starts to melt, it actually accelerates in its melting because it stops kind of reflecting the sun, and as it becomes darker, because the ice is actually melting, it will absorb more solar radiation, which will lead to increased melt. So we can see glaciers melting, or ice sheets melting in Greenland. We can see glaciers melting in Switzerland, and also in Alaska. You can see very, very dramatic photos. And we see this happening around the world, right? The impacts of anthropogenic climate change. And so this is one of the things that we can sort of relate anthropology to current problems today, looking at how ancient people ruined their own environment and how ancient people dealt with climate change, and then apply it to modern problems today. Okay, our next topic that we're going to look at this week, and you're going to have a little online virtual lab, will be on ceramics. Now that we've talked about typology and how you organize your assemblages, we're going to get into the different kinds of material culture and other things that you recover from an archaeological site and how you analyze them. So the first one we'll look at is ceramics.